Hey guys, welcome back to my channel and I hope you're doing amazing. I hope you're doing great. And in this video, we will be talking about preparation of haloalkanes using alcohol. Now, there are a number of methods for preparing, haloalkanes using alcohol. But in this, we will be talking about three main reactions that are, involved in preparing haloalkanes from alcohol. So let's see our first reaction. That is our first reaction that we are going to study here is reaction. Let me write it down here. Our first reaction is reaction of hydrogen halide and alcohol. So here I have represented ROH as alcohol. R is any carbon chain. We will mostly be using ethanol here, but you can use any alcohol you like for that matter. I have represented ROH for that, just for the sake of representing alcohol. Now here, if you take your alcohol, this is a sample reaction. If you take your alcohol and you take your hydrogen halide, what are the products that you get? So first of all, if you notice something in this, you can see that there is an OH and a hydrogen. Automatically, you know that these both are going to form bonds and they are going to, form water. And also you have R and X, you have your R group, you have your carbon group, and you have your halogen group. So you have your alkyl and halogen group. Obviously they form a bond, so you have Rx, this was your haloalkane, and you also get a water molecule as well. You also get water from this reaction. So this is the basic reaction, guys, that we are going to follow here. Here you can see that Rx, this is our haloalkane, this is our good looking haloalkane. Any haloalkane can be formed by taking this as the sample reaction, a basic reaction. However, there are some things to keep in mind as well. So let's look at these things. Let's look at some points to keep in mind. So some points to know, just some points to know that you have to know in order to understand this reaction in the best method. So first point is our reaction. Now this particular reaction, guys, it is a nucleophilic substitution reaction. Now don't worry if you don't know about nucleophilic substitution reaction. I'm going to tell you in this video what nucleophilic substitution reactions are. Basically, I'll just give you an idea so that you can understand this in a much better way. So if you look at nucleophile, the word nucleo means positive. This part of the word means positive, and this phile part means loving. So nucleophiles are positive loving species. They are positive loving species. They love positivity, they attract positivity, they are attracted towards positive, and these are mostly anionic. They're mostly anionic, which means they have a negative charge on them. When the bond breaks, they get a negative charge. They are anionic, they attract to positive, and they are also electron rich species, which means, because you guys know that any atom which gets a negative charge, which means it has got an electron, it has stolen an electron, got an electron, which means it is electron rich. So it readily shares electrons. Obviously rich people, they share, well, most rich people share. So here also nucleophiles, they have a tendency to share their electrons. They are positive loving, they have a positive attraction, they attract towards positivity. So here what happens is that, why do we call it as a nucleophilic substitution? Is there a substitution reaction going on here? Is there any substitution reaction? Let me get a better color for you guys. Is there a substitution reaction going on here, or what is happening? What is substituting what? Let me write that reaction once more here. So if you have your alcohol and you have your hydrogen halide, the product that you'll get is your haloalkane. We got that. Okay, that is clear. But let's look at this once more. if you look at here, you will see that OH and X, if you actually break this bond, R and OH bond, if you actually break this bond, OH will get a negative charge, and similarly hydrogen halide bond breaks and your halogen atom will get a negative charge, because they are both electronegative, they attract electrons, and since that happens, they both act as nucleophiles. Nu minus is the symbol for nucleophile. You represent nucleophiles. If anything you want to represent as a nucleophile, you generally write Nu minus. Now here you can see that X has replaced OH minus. It has basically the right word to use in this situation is substituted. X has basically substituted OH. That is why we call it as substitution reaction. You can see that this OH is being substituted by X, and the product that you got is your haloalkane. That is what is happening, and after this substitution you can see that X forms a bond with R and OH forms a bond with hydrogen, and the products are consecutively the same. Now when it comes to reactivity, let me tell you a bit about reactivity. Okay, let me write reactivity here. Reactivity. Now generally many important questions are asked from reactivity, but let's look at this first. Let's talk about basic trends. Let's talk about hydrogen halide. Let's first talk about hydrogen halide. What sort of hydrogen halides are more reactive and what sort are less reactive? So hydrogen chloride is the least reactive, then you have your hydrogen bromide, and then you have your hydrogen iodide as the most reactive of all the hydrogen halides. Similarly, if you talk about alcohol, this ROH is your alcohol. Your primary alcohol is the least reactive of all. This is your primary alcohol. Primary alcohol is least reactive. Then you have your secondary alcohol, which is a bit more reactive than that, and you have your tertiary alcohol, which is the most reactive. This is the reactivity order, guys, and you have to know that a lot of questions are asked from this particular part of the chapter. They generally ask you about the reactivity, which is more reactive. They might also give you reactions based upon this, and they might also ask you the rate also, because anything that is more reactive has more rate. Anything that is more reactive has more rate of the reaction. That is why we also, many questions can be framed from this, and I also encourage you guys to create your own questions. Now let's talk about some products. Let's talk about the basic products that are formed in this sort of preparation from alcohol. There are many products that are formed. There could be chloroalkane, there's bromoalkane, there's iodoalkane that is formed from from this preparation method of alcohol. So let's talk about chloroalkane. Chloroalkane, this is our first product. Let's talk about how it is prepared. Let's see the general reaction that is occurring when it comes to your chloroalkane. So if you have your alcohol, this is your CH3 CH2OH, this is your alcohol. You can also write it as C2H5OH, anything that you like, and you have your hydrogen halide. Now you are preparing chloroalkane, so you'll obviously take hydrogen chloride as your hydrogen halide. Remember, the hydrogen halide, the halogen atom taken must be same as the must be the same as the product that you want in the product. So here chlorine, you want chloroalkane, so you have to take chlorine, and you have this reaction occurs in the presence of anhydrous zinc chloride to get chloroalkane. This is your chloroalkane. Anhydrous zinc chloride is basically a catalyst here. It is an important catalyst in this reaction, and you get a chloroalkane here. Now this zinc chloride is an important catalyst, and it basically helps in removing the O. Can you see the O? The O, yes, this O. This O, it helps in removing it from the CH2OH bond. It helps in removing it from the structure. It helps in removing this O, so that chlorine can come and easily get attached to it. As you can see in the product, this O was removed along with the this O was removed, so that the hydrogen from hydrogen chloride can form a bond and chlorine can come attached to it. So that is the basic role of zinc chloride. It helps in removing oxygen atom. it helps in doing that. That you have to keep in mind. That is the basic thing that you have to keep in mind, that zinc chloride helps in removing oxygen so that chlorine can attach. So let's move on. Let's talk about bromoalkane. Okay, bromoalkane, this is our next product that is formed. Now this is not the same as chlorine. This is, there might be something peculiar, it has some peculiarity in it. It's not, the reaction does not proceed in a similar manner. There is a bit of a peculiarity, it has a speciality that I'm going to tell you just about now. So if you consider an example, if I give you an example of for the preparation of of this bromoalkane, let's say C2H5OH is the alcohol I have chosen, and you guys might think that I'll be choosing hydrogen bromide, but wait, we are not gonna use hydrogen bromide directly. Like, we don't use hydrogen bromide directly. You might be asking, then what do you do, how do you prepare this bromoalkane if you're not using hydrogen bromide? Well, we use hydrogen bromide, but we do not use it directly as a prepared product. We use it in a, we make it react with your alcohol. First we have to prepare hydrogen bromide in the flask itself. We have to prepare it in flask so that it can, after it is prepared, it reacts directly with the alcohol. Let me give you a better picture of this. Let me help you to understand this in a much better way. Suppose I want you to imagine that you have a flask, a nice flask, a nice beaker that you're having, and in it you are pouring your alcohol. You have poured in your C2H5OH, that is your ethanol. You have poured in your alcohol. It's a pretty nice flask, and you have poured in your alcohol. Now along with that, you will not pour in your hydrogen bromide. You prepare your hydrogen bromide directly. What you are going to do is you're going to put in sodium bromide, as well as you're going to put in concentrated sulfuric acid. You're also going to put in concentrated sulfuric acid. Now what is happening, why do we put these? This happens, we use this so that these two can both react and form hydrogen bromide. Yes, exactly, they both react within the flask itself to form hydrogen bromide, and then this hydrogen bromide reacts with your alcohol directly to form your chloroalkane. That is the peculiarity about this reaction, is that you do not directly use hydrogen bromide. You prepare it in the flask itself, which contains alcohol, and you prepare it by sodium bromide and concentrated sulfuric acid. So let's look at the general reaction here. Let's look at the reaction that occurs. So you have C2H5OH, and you have your sodium bromide in it, and you also have your concentrated sulfuric acid present in this part of the reaction. Now this concentrated sulfuric acid and sodium bromide both react to form hydrogen bromide, as simple as that, and then your hydrogen bromide reacts with C2H5OH. Another thing to note here, that refluxing occurs. This only happens after refluxing. After refluxing, your product is formed. Your product that is formed is your bromoalkane, C2H5Br. Your bromoalkane, you have formed your nice bromoalkane. Now you might be wondering what refluxing is. Refluxing is nothing, it's just a fancy term for boiling. For heating or boiling. When you heat something or boil something for 48 hours straight, or you boil it for 48 hours directly, constant heating directly for 48 hours, you call it as refluxing. It's just a fancy term that you can get used to. But the main thing to note here is that your bromoalkane is formed, and you use sodium bromide and concentrated sulfuric acid as your reactant in this case, and not the other way around. You did not use hydrogen bromide in this directly, but you use sodium bromide and concentrated sulfuric acid. Let's move on to our last product, that is iodoalkane. Iodoalkane, similarly is the case for similar cases for iodoalkane. We are not going to use hydrogen iodide directly. We will first have to prepare it, and we prepare it by potassium iodide and concentrated H3PO4. That is also we are using, and also this will give us hydrogen iodide. Sorry, this will give us hydrogen iodide, and this will, and the products that we will get is your C2H5i. The products that we get is your C2H5i or your iodo alkane. That is the product that we got, and that is the product that we required. Another let's I just want to take a bit of your time. I just want to extend this video shortly, just 2-3 minutes, that's it. I won't take much more of your time. I just want to give you another reaction of alcohol, that's it. Just a brief overview of these reaction. These are very handy reactions and you have to know and these reactions as well. So let's talk about the reaction of alcohol and your halogenating agents. It's not that hard, guys. Just this part you have already done. With the juicy part of the video is done, the hard part of the video is done. This is just a fancy term. This is just a it's like a normal stuff right now. We don't have any thing going on here, any hard stuff. This is just normal preparation of alcohol, of haloalkane, using a halogenating agent. We'll use a halogenating agent here. So if you have an alcohol and you use your PCl5, you use PCl5, you will get your C2H5Cl. First of all, PCl5 is the halogenating agent. Your phosphorus halide, any phosphorus halide will be used as your halogenating agent. Just keep that in mind. We are using alcohol and we are using a halogenating agent. That halogenating agent is your phosphorus halide, phosphorus chloride, phosphorus bromide, phosphorus iodide. These are all your phosphorus halides and they can act as halogenating agents. And if you react your alcohol with your PCl5, you will get your C2H5Cl or your haloalkane or whatever you're trying to prepare. If you reacted with PCl3, again you will get your C2 H5Cl or your haloalkane. It's as simple as that, guys. Nothing to be scared of, nothing to worry about. Just doing our own thing, just preparing haloalkanes. That is what we are doing right now. Again, if you use your potassium bromide, you in the presence of red phosphorus and bromine, you will get your C2H5Br. And also if you use your potassium iodide in the presence of red phosphorus and Br2, these act as catalysts. These are just acting as catalysts. You can write them down if you want to, but this was just a normal overview that you can get. These halogenating agents can be used to give you haloalkanes as well. That was also about these reaction. The main thing to note here is that the main halogenating agent used here is your phosphorus halide. The last reaction, guys, I'm just taking 2 more minutes of your time. That's it, 2-3 more minutes, and I won't take much time. Thus I'm going to wind up with this video. The reaction between alcohol, this is our last reaction, guys, using alcohol. Reaction between alcohol and, yes, what do you call this term? What, how do you pronounce this term, or how do you say this? SOCl2. Guys, this SOCl2 is thinyl. It is your thinyl chloride. Yeah, it kind of seems pretty, I don't like that term. It's really annoying. I don't like to learn these fancy chemical terms. I don't like them at all. Yes, but anyways, let's just keep in mind that you have thinyl chloride. Your SOCl2 is your thinyl chloride, and your general reaction that is occurring here is your C2H5OH, and you have your thinyl chloride that is being used. So when your thinyl chloride reacts with C2H5OH, the products that you get are C2H5Cl. This is your haloalkane, guys. This is the main product that we want. Along with that, we also get some other products. We also get hydrogen chloride, we also get HCl, and we also get SO2 gas, which is evolved after the reaction. So that was about the basic thing that we had to keep in mind. Another thing about this reaction, another peculiarity about this reaction, that this reaction, guys, this reaction is called as Darzin's reaction. Not Tarzan, not that jungly guy, that Tarzan, not that guy. It is Darzin's reaction. And guys, this is the best method that you can ever have, you can ever get, you can ever use to prepare chloroalkane. This is the best method to prepare chloroalkane, and perhaps it is, mostly it is used in laboratories as well. Darzin's reaction is the best method for preparing chloroalkane. That was about your reactions, different reactions from alcohol. That was basically the main theme of this video for preparing haloalkanes using alcohol. And thanks for watching, guys. In the next video I will talk about some, some 2-3 methods more to prepare haloalkanes, and that's it. I won't take much of your time. Thanks for watching. Make sure you guys subscribe and like this video, and as always, take it easy. Have a great day ahead.